Okay, so this is the VELP UDK 129 laboratory distillation unit. I'm using it to distinguish between free ammonia and amines, amides, other types of ammonia locked up in organic molecules. So the way this works is I put my sample in this large test tube here, and I've got a distilled water reservoir and a cooling reservoir with tap water. So it's all automated. What'll happen is the machine will take in distilled water, it'll generate steam from it, and it'll inject the steam down into the sample. That steam will then carry up to a condenser, which is cooled with the cooling water, and will eventually generate some distillate over here. So I'm pre-measuring the amount of sample I'm using first, and I'm also weighing the amount of distillate collected to correct the numbers that I receive for weight differences. So all I have to do is press the start button, and it'll start a 5-minute timer where it will distill that sample for 5 minutes. So in a second now you'll see the bubbles start there as the steam starts to generate. Okay, so we're a minute in to the process, and we've got a really high volume of steam being generated there now. Okay, we're about halfway through the cycle, and you can see there's a steady flow of distillate being condensed into the distillate flask there now. Okay, I'm in the last few seconds of the cycle, and we're going to see the unit shut down. So what should have happened here is all of the free unionized ammonia, basically dissolved ammonia gas, should have transferred over with the steam generated over the 5-minute period, so transferred from this vessel over into that one. Whereas the heavier, larger molecules of amines and amides would have remained with the original sample over here. So we'll wait for the last of the condensate to drip down there, and then we'll perform our ammonia analysis on that one. We'll correct for the weight difference between the original sample and the amount of distillate collected, and we'll compare the results. So the final step with the equipment is to just flush the unit with some distilled water. So all I did was I added some distilled water to the test tube and ran that through the distillation unit, and that cleans out any residue from the last test. And the final step is some calculation. So I measured the ammonia concentrate in the original sample after distillation, and I got a non-detect. So the ammonia in this side after the distillation is basically not detected by my test method, whereas the ammonia detected in the distillate was measured at 61.5. So I've got a known stock solution I measured before I started is 67 ppm. I measured the mass of sample that I used to distill, which was 100 grams, and I measured the mass of distillate collected, which was 106 grams. I have to correct for the difference in volume for those two, so the calculation is the mass of the distillate over the mass of the sample, which is 106 over 100, which is 1.06. So my calculated ammonia concentration in the original sample after distillation is the concentration of ammonia in the distillate times the volume correction factor, which is 61.5 times 1.06, which is 65.2. Percent difference is 65.2 minus 67 over 67, which is 2.68%. So very good agreement between the known concentration of the original sample and what I calculated after my distillation. And again, just to demonstrate that the ammonia was all carried over, I measured the concentration of ammonia in the test tube after the distillation was complete, and I got a non-detect.